right, hey everybody. Let me get this adjusted slightly. All right, thank you for joining me this afternoon. I'm excited to talk about MotherDuck and the AI Lakehouse. I'll quickly introduce myself. So I actually come into the data world, the streaming world broadly, through finance and accounting. I actually did accounting as my undergrad degree along with computer science. But I kind of found myself, running shorter and shorter batches, which is kind of funny. When I look at where we are with streaming today, I kind of laugh because I've always kind of worked on data pipelines. It just initially they ran 12 times a year. Yeah, I'm excited to talk today. If you want to follow me, by the way, on Twitter, I sometimes get to post funny things on there. So the first thing I want to talk about is kind of three lessons around, not lessons, that's the wrong word, but like a brief history lesson around three things that we've kind of recognized and have made things interesting for us at MotherDuck. The first thing is this chart and this inflection point. So for those of you who kind of come from the world of big data, you'll know that this is around the time that Google started writing these research papers, right? This is Google File System. This is MapReduce, a big table. So they had big data. They had a lot of problems that they were trying to solve. They also kind of had an interesting problem that occurred at this time too, which is they assumed that the architecture would look like this. And what actually happened is it looked like this, where the clock speeds kind of just stayed flat. So that's the first thing. The second thing here related to this is around the same time, we started adding more cores to our processors. And that means that when you had to think about distributed compute, like circa 2005, if you want to run something on, 64 cores, you're thinking about 32 or 64 machines. Today, you can run that on a single machine. So an interesting thing happened here, which is, Moore's law actually held, even though our clock speeds for the first time started slowing down. They like to say past performance does not guarantee future results. Apparently that's not true for this guy. This is Gordon Moore. Moore's law is held, but architecture has changed. So the next thing I want to talk about is price per gigabyte of storage. So in 2005, it was about $2 gigabyte. Today, it's less than a penny. And if you're good at negotiating, I think it's maybe even half or a quarter of that price, according to people who know things at AWS. So it's getting way cheaper. It's also getting way faster. We're now at, what is that, 30x faster in terms of what we can read from a disk. And so storage is order of magnitude cheaper and faster. When we talk about big data as dead at MotherDuck, this is what we mean. We don't mean you don't have big data. What we mean is the hardware has out-accelerated the size of our data. There's one more thing I want to talk about here too. This is my third point, inference. So if you looked at GPT-3 in June of 2020, it was $20 for a million tokens. We're now at 5 cents approximately. So we've really dropped in terms of price there. And so we have this other thing that's happening, which is inference is also getting orders of magnitude cheaper and faster. And so here's the kind of three things that have set us and led us to today where we are with MotherDuck, right? Laptop today, 3,000 times faster than the server from 2010. Storage, 200 times cheaper, 70 times faster, and inference is, down 99.7% decrease in cost since 2020. So that brings us to this notion of the AI Lakehouse, and what does that mean? I pulled this off of Dremio's website. I thought it was good, right? Data Lakehouse. This takes the best things of a data lake and a data warehouse, and it puts them together. By the way, also a 2006 movie starring Keanu Reeves and Sandra Bullock. I don't know if any of you have seen it. It's also curiously about time travel. Anyways, very, very funny. Lakehouse is a superset of data warehouse. So when I talk about things, I may interchange them a little bit. So what is it for, right? When we think about what these things are for, what do we mean? From a business perspective, you can think about a single source of truth. Maybe, Gartner said you need it. Maybe it makes you more hireable. It's more of a swamp. It just kind of has things in it. Or you don't know. What I think about when I think about these tools is these are for solving business problems, right? But business problems are hard to solve, as it turns out. You kind of have to have this layer of all of these pieces, and they need to be together in order for you to solve problems, right? If any one of these four things doesn't work, you can't solve the problems you're trying to solve. And so one thing that has happened kind of in the context of our single nodes becoming much faster and cheaper and having much more storage is a project that came out of Netherlands called DuckDB. And DuckDB is a in-process analytical database. It is MIT licensed open source. It's very fast. The team there is totally obsessed with performance. The best way to get a change handled in their backlog is to show them a chart where they're number 2, and then they'll fix it in about a week. I know that from experience. So that's DuckDB. The next thing that we need in order to solve these 4 things is a common language, okay? And for better or for worse, what goes around comes around. And we have a common language. It's already been here. It's SQL. It's been here for 50 years, and it'll probably be here for the next 50. This is a great paper by Michael Stonebreaker and Andy Pavlo about SQL and how it has kind of absorbed all of these great features that have been built out over time. Highly worth reading if you have some time. So what does this mean? We can take DuckDB and SQL, and we can solve business problems in an epic way. And that is what we are trying to do with MotherDuck. There's a small problem with DuckDB, right? It's just a library. It's open source. If you want to use it in your enterprise, it's fine to embed it maybe in a Docker image or something. But if you want to actually use it to serve data to customers, there's some things that are missing, like a catalog, like differential storage, like database sharing. There's some other stuff too, but that's the things that we're focusing on adding at MotherDuck. So let's revisit kind of this list of problems. The first thing you need in order to solve business problems is you need good ingestion. And this is a very small piece of a diagram I'm sure you've all seen that is huge and has, I don't know, a lot of logos on it. You probably have to pick 3 or 4 or 5 of these to really kind of solve a business problem from an ingestion standpoint. Or maybe you can use DuckDB. If you have data in CSV, JSON, Parquet, or Delta, DuckDB can read that with SQL. If you have data in AWS or GCS or Azure or Cloudflare, DuckDB can also read that. Data frames, totally fine. REST APIs, totally fine. Google Sheets, Excel, also can read that. You have data in a database, again, using SQL and DuckDB. Postgres, SQLite, BigQuery, MySQL are all supported today, and I'm sure more coming. Just so you know that I'm not just making this up, here's an example of what the SQL looks like to read JSON into your database. Select star from a local file. We can also do things like read from an S3 bucket. Right? Here's a Parquet file in an S3 bucket. Here's an example of a CSV file. Here's an example of reading directly from a Postgres database. And then last, here's an example of attaching, which is this notion of a kind of linked server or like a foreign data wrapper, if you're familiar with that. In Postgres, we can just represent that as a name in an object in DuckDB, and then we can just query the tables. So if that's not enough, of course we have a ton of connectors that you can natively use to rip data straight into your data lake or, of course, into the database. I think it's a pretty good combo. That's a pretty good set of features. I think ingestion is something that we can say we can solve. What about good transformation? Good transformation is also hard. There's been a lot of tooling built out recently. One of my favorites is DBT. It's a SQL-based transformation tool. We do a little bit of trialing on it. Just as an example, this comes from our talk we did at Coalesce. We were running a 300 million row kind of data set, including data loading and a bunch of testing and validation. Took 40 seconds. By the way, that's on an M1 Mac. If I run it on my Mac, it takes 20 seconds, which is M3. And if I skip the loading step, it takes 10 seconds. So this is a full pipeline running in 20 seconds that is 300 million rows of data. It's fast. The second thing is it integrates very nicely with Python. And here's an example of that. So if you can define a data frame, and then you can select it inside of your Python environment and add it very easily into a DuckDB database. Now you can use SQL on top of it. This really helps when there's complex transformations, right? Sometimes, like as much as I love SQL, it can be a little verbose. It can be maybe doesn't have the right libraries you need to solve the problem at hand. Slide it in there, use Python, connect it right in. So good transformation. I think we have a good solution there. Analysis, this is one of my favorite parts. They're doing a lot of interesting things with DuckDB, and we're extending that with MotherDuck. The first thing is, if you want to do some classical machine learning, why don't we just make those SQL functions, right? That's easy. If you're doing decision trees, right, sklearn, for example, you can use something like JoinBoost, which uses DuckDB behind the scenes and Python. Very great performance. And again, integrates straight into SQL very easily. You want to do a little bit of k-means? Great. There is also a k-means SQL function. Hopefully you guys see what I'm getting at here, which is if you have a hammer, everything looks like a nail, right? So we are going to continue to use and abuse the SQL hammer. And we're going to go into the next step here, which is what about natural language to SQL? One of my favorite things that we can do with DuckDB is this notion of reservoir table sampling. Well, I never remember what the syntax is, so how do I find it? I could go look at the docs, or I could be really lazy, and I could just ask Olama, and we actually have a model called DuckDB in SQL that we trained that can do things like answer these types of natural language questions and return SQL to you. All locally, which is really cool too, no dependencies. You can run it on your laptop. Now, of course, we're also benchmarking this. Like, does it actually perform well? Like, what does it look like? We do this with Hugging Face. And you can see that currently our model it's not the best model for actually writing DuckDB SQL. But we're working on training a new one. So that will be out soon, next few months. And hopefully we'll regain our rightful spot on the top of the leaderboard here to enable kind of some natural language SQL stuff. Okay, now we're getting to the really fun parts. Text processing in SQL. So 50% of columns in SQL are strings. So what that means is these small models are actually very effective at helping us understand them. And they're very powerful, and they're continuing to get more powerful. So one thing we can do, just as an example, kind of end-to-end, is pull data into DuckDB and MotherDuck, and then kind of do fun transformations on them with AI. And so I'll show the example here. This one actually comes from a personal story. My buddy said, "Hey, I'm ordering some wine. Do you want me to add anything to an order for you?" And I said, "I don't know anything about wine, but maybe I can find a way to solve this problem with data." And so I took the file he sent me, I put it in a CSV, I pulled it into my database, and now I have a wine list, but all it has is the region and the name, and it doesn't really tell me anything about the wine. So how do I learn something about it? Well, what if I have ChatGPT do that? So I can write, using this prompt function, I can actually pass prompts in parallel using SQL and get back a product description. So in this case, this data set is 2,450 rows. It takes about 48 seconds to run a prompt on every single one of those rows and get back a response. So we actually run that kind of in parallel behind the scenes. So once we have descriptions, well, I can't really use those yet because there's just too much data. So what if I can turn those descriptions into vectors with embeddings? So the next thing I do is I just take that list, those prompts, and I put embeddings on top of them, right? This takes about 8 seconds. So now stored in my data set in this wine list embeds table is that original data plus a description plus embeddings. So what's really fun is now I can use that again to make an on-the-fly recommendation, right? So arbitrary text going into a SQL query, returning a list of data. Excuse me. So that's kind of fun. That's a fun toy. I used it to place an order for wine. The question is like, is the recommendation actually good? Like, are we just hallucinating something here? So I did a little bit of investigation. There's more classifying you can do. In fact, actually, I will maybe after this I can show you all a example of a judge you can implement in SQL. But we'll get there when we get there. So here is the prompt that was generated for this bottle of wine, this 2018 Talbot, using our integration with ChatGPT. And here's an actual description that someone wrote at Wine Advocate. Are they close to each other? Well, they both mentioned the color, which is what was in the original prompt, which is great. They both mentioned blackcurrant, which was also in the prompt that I gave it, and they both mentioned earthiness, which I didn't mention, but is part of this type of wine. So I think that's actually pretty good in terms of where we can get to from a very sparse data set, enriching it with an LLM, and then doing on-the-fly recommendation. So let's just talk about what just happened here. We read a file in, we used a prompt to add a description, we added an embedding, we compared arbitrary text against the embedding, we returned a scored result set, and we did it all in SQL. Again, if you just have a hammer, everything is a nail. Okay, so those are the types of analysis that you can do purely in SQL with DuckDB. So let's talk about flexibility when things change. So typically when you think about kind of who are the people using these kind of tools, we have three kind of areas, right? We've got our business users, we've got our data scientists, we've got our data engineers. And one thing that we discovered actually in surveying the users, actually the DuckDB team did this, not us, that 23% of users who are using DuckDB are actually software engineers. So this is not just a tool for people kind of in the data space, this also can extend into software engineering. And what I love about that is it helps us understand how flexible this tool is. And I think what I just showed you all with AI also leads us into something pretty cool here, which is it's easy now for me to shift left or right from a role to solve the problem that I have at hand, right? If I'm a business user, I can shift right into more heavy analysis. If I'm a data engineer, I can shift left. If I am a data scientist, I can kind of vary between the different spots. And so I think that really, for me, hits on what the power of this is from a flexibility standpoint, that you can easily move to where the ball is in terms of the problems at hand. So in my mind, that's flexibility when things change. I think we did that. So what are the three takeaways kind of from what I'm thinking here with MotherDuck and DuckDB, right? The first thing is things have changed. Our architecture is different. We need something new to take advantage of that, right? Second thing, DuckDB is built to take advantage of the throughput that we have on a single node. And the last thing is, of course, MotherDuck is extending this functionality to the cloud to solve enterprise problems. That's all I got. Thanks, everybody.